Next, we have geometric sequences. A geometric sequence is a sequence in which each term is generated by multiplying the previous term by a common multiple, sometimes called a multiplier. Our example here, we have 6 for our first term, whoops, and then we have 12, and then we have 24. So I'm looking for what number I multiply 6 by to get 12, that I would multiply 12 by to get 24. In this particular case, that would be times 2. So you see here in this example, each term is found by multiplying the previous term by 2, the common multiple. The same common multiple must be used every time to make the sequence geometric. An exponential model, this would be new for us. G of n equals a times b to the nth power can be used to represent a geometric sequence. Now, this is specific. Some of these letters are a little different and they look a little different than our typical linear model. The number out in front is always going to be your term 0. So we're still using term 0, sometimes called initial value. The b, the number inside the parentheses, the number that has the power, is your multiplier, or your common multiple. So we still need those two pieces, the same as we did during arithmetic, except we're arranging them slightly differently, and our variable is now the exponent. So in this example, 2 is the multiplier. We figured that out up here, times 2. Same as arithmetic, if I know the first term is 6, I must go backwards once to get my 0 term. So if forwards is multiplication, then backwards would be division. So 6 divided by 2 gives me that 0 term of 3. Let's take a look at a couple examples. Write the next 3 terms of each sequence, and then write a rule for each sequence. So first we have 4, and then we have 12, and we have 36. Now, if you struggle to figure this out, what number we're multiplying by each time to get the next term, you could always divide them or use guess and check on your calculator to figure that out. In this particular case, we're timesing by 3 for each of these. Okay, so if we were to write the next 3 terms, which is what the instructions tell us, the next term would be 108. The term after that would be 324. And finally, our last of the 3 terms we must write would be 972. We're simply taking each number and timesing it by 3 throughout. Again, a calculator would come in handy here. So as I start to write my equation for geometric, remember my n value is going to now be an exponent. That multiplier number goes inside the parentheses, and then my term 0 goes out in front. So I must again go backwards 1 to get that answer. So 4 divided by 3, we will just leave as 4/3. Because if we try to actually use our calculator to get that answer, we'll end up with a repeating decimal, and that's no fun. Take a look at the next example. I have 48, 24, and 12. These are going down each time. So just like before in our arithmetic sequences, we were decreasing, we used subtraction. Now for geometric, adding and subtracting are out, we're thinking about multiplying, and the converse of multiplying is dividing. So in this particular case, what number are we dividing by each time, or what fraction are we multiplying by? So here, 48 divided by 2 is 24, divided by 2 is 12, divided by 2 would be 6, 3, and 3 over 2, or 1.5, for my next 3 terms. And next I write my sequence. So again, the different model here has parentheses with the n as the exponent. The multiplier, which we just said was dividing by 2, but remember that's the same as multiplying by 1/2. So our multiplier here is 1/2, or 0.5. Again, I must go backwards 1 to get my 0 term. So if I'm dividing, backwards would be timesing. So 48 times 2 then gives me my term 0, in this case 96. And finally, I get some messy fractions here for this last one. All right, this one's a little trickier. This is more challenging. What am I multiplying by each time? All right, and you know, to go from, with the numerator staying the same, 3 over 4, 3 over 2, 3 technically over 1, okay, then the numerator's not changing, only the denominator's changing. That means I'm multiplying by a number bigger than 1 because my numbers are growing. So what number is that? Well, if you think about these as decimals, since it is possible here, this is actually 0.75, and this is 1.5, and this is 3. And that might actually make it easier for some of you to realize that my multiplier here is times 2. So if I write my next 3 terms, I'll have 6, 12, and 24. So my equation, again, it's going to be that multiplier of 2 to the n power. And I must go backwards 1 again to get that previous term. So if you're not a fan of fractions, you could just take 3/4 divided by 2 on your calculator and change it to a fraction. Or you could take 3/4 and dividing by 2 is the same as multiplying by 1/2. So 3 times 1 is 3, and 4 times 2 is 8. So 3/8 would be my term 0. That's a little trickier, but we'll be looking at the basics for both arithmetic and geometric sequences.